All right, chapter 3, section 2, we get to talk about logarithmic functions. So they have a nice definition of logarithmic functions, but the main thing that you need to get comfortable with is how to go in between an exponential function and logarithmic function. So before we look at a couple problems in WebAssign, I want to take an exponential function like 5 raised to the x. Again, it has this nice feature, exponential growth. What a log function is, it is the inverse of an exponential function. And so when we're talking about inverses reflect across this y equals x, and it solves for the other thing. Like if I have a point here, then I'm also going to have the opposite point, not the opposite, the flipped point on my inverse function. So let's show that. So if I have the point 2 comma f of 2, right? So I get a point, let's go a little lower, 0.5 and f of 0.5. That should get me on the graph. So I have this point here. If I were to graph it backwards, f of 0.5 comma 0.5, I get a point that's reflective across this y equals x. And it's on my log function. So an exponential function and a log function are just inverses of each other, which means their points just change places. Instead of having xy, I have yx. Excuse me. So that comes in handy when we're trying to solve exponential equations or logarithmic equations. So make sure you're reading the chapter, getting a good skim on, so when you do the problems, they make a little bit more sense. A few I wanted to look at is number 1. So this is just rewriting it. And so you take your base, if you have a log equation, log base 9 of 1 over 81 equals negative 2. What negative 2 represents is your exponent. Your base is 9. 9 raised to the negative 2 equals the 1 over 81. So your base is your base of your exponential. This is your exponent, because again, we're solving for the other thing, equals the 1 over 81. Also looking at number 4, if it doesn't have a base down here, it's assumed that it's, if it's a log, it's a base 10. So this one just wants you to evaluate it on a calculator. Log base 10 of 10,000. And so we could do that on Desmos. So it's log base 10 of 10,000. And we get their answer of 4. Now this is the same thing as saying 10 to the 4th power equals 10,000. Right? If I wanted to convert back to an exponential, 10 to the 4th equals 10,000. So again, when we have a log, we are solving for the exponent. So log base 10 of 10,000 represents my exponent if it was an exponential form. 10 to the 4th equals 10,000. Another one to look at is number 11. And so write the exponential equation in logarithmic form. Well, if this is my base, so taking an exponential and writing in base, so it'd be log base e of 5 equals 4x. So we don't have one that says log base e. So what ln stands for is just the natural logarithm. So that is your log base e. So log base e of 5 equals my exponent of 4x. And that's why it's this one down here. So it's log base e, because this is my base of my exponential, of 5 equals the 4x. So you really need to get comfortable moving those around. Graphically, these have the same properties that exponential and the other functions that we've talked about do. So let's look at log base 4 of x. So log base 4 of a number. Well, notice that if it's 4, log base 4 of 4 equals 1. Right? And that's because 4 to the what power equals 4. And it's 4 to the first power. If we go out to 16, we would see that log base 4 of 16, when my x is 16, oh, let me get right on it. I'm close. Close enough. Log base 4 of 16 equals 2. Right? Because 4 squared is 16. So here's that graph that we have of this exponential function. If I am to add 1 to it, or let's add 4, that means I just went to the left 4. I still have that vertical asymptote. On my original function, my vertical asymptote's at x equals 0. But if I shift it 4 to the left, my vertical asymptote is at negative 4. If I subtract 4, again, it's to the right. If I multiply it by a number, it gets stretched on the vertical. If I multiply it by the negative on the outside, it gets flipped on the x-axis. If I change the sign of the x on the inside, it flips it on the y-axis. So it has all those same properties that everything else has. Oh, and I could move it up or down. -8 is just moving it down, right? So these are all similar properties of exponentials and the other functions that we've talked about. So won't have a supplement for this one. This one just is getting comfortable with going from 2 raised to the x equals, oh, let's say something that we know is 16. You already know that x is equal to 4. But in base form, it would be log base 2 of 16, and it would give us the answer of 4. It's a way to solve for the exponent. And I think it's section 4, how are we going to find this answer? 2 to the what power equals 10? I don't know. That's somewhere in between, well, 2 cubed is 3. 2 to the 4th power is 16, so it's somewhere in between 3 and 4. And again, using log equations, we can find that number. So that's where we're going to in section 4, is solving for variables and our exponents by manipulating them. All right, so there's your chapter 3, section 2.